Welcome back. Today we are going to look into practical problems. This topic is about applying what we know about right-angled triangles and non-right-angled triangle trigonometry into real-life questions. So before we move into our example, let's just do a little review and a little recap. So 2 skills for us to solve a right-angled triangles. If we look back on the lessons for 3D objects and worded 3D problems, the first thing that comes to mind is SOHCAHTOA. Okay, SOHCAHTOA helps us find the angle or side. And the second skill is Pythagoras' theorem. Okay, Pythagoras' theorem helps us to find an unknown side. Okay, that's a small review for right-angled trigonometry. Let's delve into non-right-angled trigonometry. So area of a triangle. We need to look for a specific thing to use the area of a triangle, okay? Or to know when to use the area of a triangle. So let's say we know what angle C is, right? And we know what angle B and what angle A is. One thing that I need to look for is a TP type of shape, okay? That's what I need to look for, TP. So let's just put in our formula here. Area of a triangle equals to half times length A times length B times sine C. Okay, that's what I need to look for area of a triangle. For sine rule, we need to have the following. Let's say you have in your question, you're trying to find what length B is. You know what angle B is. You know what angle C is. And you know what length C is. Okay. What I need to look for is, I need to look for a cross to use sine. Okay, I need to look for a cross. Okay, let's write our formula then. A over sine A equals B over sine B equals C over sine C. Okay, depending on what we're gonna find, we either flip it to make it as sine A over A equals to sine B over B equals sine C over C. Okay, depending on what we're trying to find, whether it's in side or an angle. For cosine rule, okay, for cosine rule, let's say I'm trying to find what angle C is, but I know what the length C, B, and A are. Okay, I need to use the following formula, and before I look at the formula, I need to find out what I need to look for to use cosine rule. If I don't know what angle C is, let's just first draw a line to its corresponding side. Then use the other two lengths and make a TP. And it looks like I need to look for an arrow. If I see an arrow, that means I use a cosine rule. Okay, cosine has 2 different types of formulas. The first one is C squared equals A squared plus B squared minus 2AB times cos C, or cos C equals to A squared plus B squared minus C squared all over 2AB. Okay, so 2 formulas for cosine, and I need to look for an arrow. That's my little review. Let's go into our question. Okay, a ship sails 40 kilometers on a bearing of 32 degrees true bearing, then sails 40 kilometers due east. Find the current straight line distance from the starting point. Okay, I need to draw a diagram. Okay, trigonometry, you always need to draw a diagram. Let's say this point here is my starting point. This is where my ship starts. And it sails 40 kilometers. Okay. Let's say that is, what a elongated line. That is 40 kilometers. Okay. on a bearing, right, on a bearing of 32 degrees. Okay, let's say. Now, after that, the ship sails 40 kilometers due east. If this is north, right, if pointing up is north, then east should be going to the right. Let's say that is east, and that is 14 kilometers. Okay, what I'm trying to find is I'm trying to find the current straight line distance between my starting point and where I stopped, or where the ship stopped. Okay. All right, let's see. There's a few things that I need to find. I need to actually find what this distance is. Okay, do I have enough information? Well, I've got 2 side lengths, three side lengths, and I need to find one of them, but I don't have an angle, right? It can't be a right angle triangle because it doesn't look like it. So that's out of the picture. Then it doesn't look like an area of a triangle because that's not what the question is asking. Okay, it can be either sine rule or cosine rule. All right, let's see. Sine rule, I need to find an x. Here, it kind of doesn't seem like an x, but we'll see. Okay, if I were to draw this north distance here, right, cut it across, and I see, well, doesn't this here look like 32 degrees? It kind of looks somewhat like 32 degrees, so I'm just going to call it and assume that it is 32 degrees, right? It kind of looks like an alternate angle. Then, if I were to say, right, the ship sails due east. If it's due east, that means this here is 90 degrees. Therefore, if it's going to make a straight line, this must be 90 degrees too. Okay? Okay, let's just draw it one more time. Again, we're going to isolate our drawing. Right? This is 14 kilometers. This is 40 kilometers. And this here, right, that distance is, that theta is theta equals to 32 degrees plus 90 degrees, which should equal to 122 degrees. Okay, so just write it down. That is 122 degrees. And I'm trying to find what this is. All right, doesn't seem like it's going to be sine rule, but let's double check. I'm trying to find what my unknown side is. So let's just draw a line to its corresponding angle, right? And I've got 2 side lengths, so I'm going to make a TP. Looks like I need to use cosine, okay? So let's do it. I'm going to use cosine. Trying to find an unknown side, so it's going to be c squared equals a squared plus b squared minus 2ab times cos c. Let's substitute. Okay, x squared equals to 40 squared plus 14 squared minus 2 times 40 times 14 times cos 122. Okay, let's put that into our calculator, right? And it should get us to 2,389.509276. Okay, I need x to be by itself, so I need to square root that. Okay, just like so. And you should get, if I put that into my calculator, you should get 48.88 kilometers. And that should be it. Have a good one. Bye.